Welcome to the 75th episode of Paper Brief, where we dive into the world of cutting-edge research. I'm Charlie, your host, joined by the brilliant Cleo, an expert in tech and machine learning. Today, we're unpacking the intriguing paper titled GIVT, Generative Infinite Vocabulary Transformers, a fresh-off-the-press gem from the world of computer vision. So, Cleo, this paper introduces something called a Generative Infinite Vocabulary Transformer. Sounds like a mouthful, but could you break down what that's all about?
Absolutely, Charlie. The GIVT is a new concept where instead of using discrete tokens from a fixed vocabulary like traditional transformers, it generates sequences of real valued vectors. This essentially means the transformer's vocabulary is infinite since it operates on continuous distributions.
That seems like a significant shift from standard methods. How does that impact image generation or other tasks in computer vision?
It's a game changer. By embedding real valued vectors instead of discrete tokens, GIVT can better capture fine-grained details in image generation. This increased capacity for detail is expected to improve quality, especially in dense prediction tasks.
I'm curious about the training process. The paper mentions something about VAE and GIVT training. Can you shed some light on that?
Sure, they use a two-part training approach. First, they train a variational autoencoder, or VAE, to establish a latent space. Then GIVT is used to model this space. Despite the simplicity, it's quite effective, avoiding complex training techniques required by other approaches.
Fascinating stuff. And what about the quality of the generated images? How does GIVT stack up against other models?
They've shown that GIVT can outperform traditional VQGAN in causal modeling and even rivals MaskGIT in class-conditional image generation. Essentially, GIVT paves the way for high-quality image generation with fewer limitations.
What challenges do you foresee this model might encounter in practice?
One possible challenge could be handling the complexity and length of sequences, especially for high-resolution images. However, the GIVT design tackles this by operating in a compressed latent space, smoothing out the process.
Before we wrap up, can you tell us about the sampling techniques they mention, like temperature sampling and beam search?
These are classic methods adapted for GIVT's continuous approach. For instance, temperature sampling modulates the randomness in generation, and beam search helps in finding more optimal sequences. This enhances the flexibility of GIVT in different scenarios.
As always, the depth of this paper is incredible. Thanks for breaking it down with us, Cleo.
It's always a pleasure discussing these advancements. Thanks, Charlie.
That's all for today's episode of Paper Brief. We'll be back with more insightful discussions on the latest research papers. Till then, keep pondering the pages.